For years, Boeing has struggled to get their Starliner spacecraft right. This project was supposed to be up and running years ago, but it faced constant delays and problems, frustrating everyone. Many began to doubt if the spacecraft would ever be fully operational. In 2024, however, Boeing seemed committed to redeeming itself by launching a successful crewed mission to the International Space Station, ISS. Yet, once again, they faced numerous issues. They had planned multiple launches, but problems kept coming up, forcing them to cancel the missions. The most recent issue was a helium leak. After a few days, they decided the problem wasn't too serious and managed to launch the astronauts to the ISS. But now, that same problem has resurfaced, and we're here to talk about it. Before we dive into the details, please subscribe to our channel for updates on this spacecraft and more. Boeing's Starliner spacecraft has faced delays and challenges since it started. The project, meant to restore America's ability to launch astronauts from U.S. soil, began with high hopes and a big investment from NASA. In 2014, NASA gave Boeing a $4.2 billion contract to develop the Starliner as part of its commercial crew program. The goal was to have a reliable spacecraft ready by 2017. The need for a new spacecraft became urgent after the Space Shuttle program ended in 2011. The Space Shuttle had been America's primary means of human spaceflight for 3 decades but had significant safety issues. The Challenger disaster in 1986 and the Columbia disaster in 2003, where both shuttles were lost along with their crews, highlighted these concerns. With the shuttle program retired, the U.S. had to rely on Russian Soyuz spacecraft to transport astronauts to the ISS. This dependency was costly and politically sensitive, making it clear that America needed its own way to launch astronauts again. NASA's commercial crew program aimed to develop new spacecraft through public-private partnerships. Alongside Boeing's Starliner, SpaceX's Dragon spacecraft was also developed. SpaceX's Dragon has been very successful. It completed its first crewed mission, Demo 2, in May 2020. This historic flight marked the first time astronauts launched from U.S. soil since the end of the shuttle program. The Dragon has become the most reliable spacecraft for sending astronauts to and from the ISS, completing multiple missions without major issues. SpaceX's success has made many question why Boeing has struggled to deliver a similar spacecraft despite receiving almost double the funding from NASA. Starliner's first flight to the ISS was in 2019 but was cut short due to multiple software issues that prevented it from reaching the station. One primary issue was a timer error. The spacecraft's mission elapsed timer was set incorrectly due to a software bug, causing an 11-hour discrepancy. This error prevented the thrusters from firing at the right time, leading the spacecraft to use more fuel than expected, which ruled out the planned docking with the station. Additionally, a valve mapping error affected the thrusters in the vehicle's service module, which are responsible for performing a disposal burn after separating from the crew module before re-entry. Had this error not been corrected in time, it could have caused a collision between the service module and the crew module, potentially damaging the capsule's heat shield. A second uncrewed test flight for Starliner was scheduled for 2020 but faced multiple delays, finally launching successfully in May 2022. This mission provided the necessary data to move forward with a crewed flight test. However, the path to the crewed test was not smooth. On June 5, 2024, Boeing's Starliner finally launched with NASA astronauts Butch Wilmore and Sunita Williams on board. The spacecraft docked at the ISS the next day. The mission's primary goal was to conduct a comprehensive on-orbit test of the spacecraft, initially planned to last about a week. However, this mission encountered several issues even before launch. One significant problem was a helium leak in the spacecraft's propulsion system, detected during the countdown for a launch attempt on May 6, 2024. Initially, engineers believed the leak was minor enough to permit the launch, but further tests showed it persisted, causing a delay to address the issue. The helium leak was traced to a flange in a thruster within the spacecraft's service module. Engineers tried to tighten bolts around the leak and performed additional tests to ensure the system retained sufficient performance and redundancy during the flight. Despite these efforts, the helium leak caused multiple delays. The launch was rescheduled several times, finally taking place on June 5, 2024, after NASA and Boeing determined the leak was stable enough not to pose a risk. Even after reaching the ISS, Starliner faced additional challenges, such as thruster glitches during the docking process, which engineers monitored and addressed. Initially scheduled to return to Earth on June 18, Starliner's mission faced multiple delays, pushing the return date to June 22, and it may extend even further. One main reason for the delay was the discovery of the helium leak we just talked about. During its time at the station, the crew and engineers continued to address the helium leak and other issues, such as a sticky oxidizer valve and faulty thrusters. This extension was also necessary to allow the crew to assist with a scheduled spacewalk on June 13 and to complete additional system checkouts of the spacecraft. The long-term goal for Boeing's Starliner is to support 6-month missions docked at the ISS. During this extended period, NASA astronauts Butch Wilmore and Sunita Williams will perform several critical tests and drills. They will conduct a hot fire test of 7 of the spacecraft's 8 aft thrusters to ensure they are working correctly and review hatch operations to guarantee the safe and reliable sealing and unsealing of the spacecraft. Additionally, they will perform safe haven drills, preparing the capsule for potential emergencies by simulating scenarios where the Starliner would serve as a refuge in case of issues aboard the station. Despite these ambitious plans, Boeing's goal of making Starliner commercially operational by 2025 seems challenging given the persistent technical issues the spacecraft has faced. These issues not only delay current missions but also cast doubt on the spacecraft's readiness for long-term routine use. Moreover, Boeing's choice of rocket launcher has also been a point of contention. The United Launch Alliance's Atlas V rocket, which currently launches the Starliner, is reliable but costly and not as versatile as some newer alternatives. The Atlas V's high cost per launch and its reliance on Russian-made RD-180 engines have raised concerns about its long-term sustainability and geopolitical implications. In contrast, SpaceX's Falcon rockets offer a more cost-effective and flexible solution. The Falcon 9 and Falcon Heavy rockets have demonstrated high reliability and reusability, significantly reducing the cost per launch. SpaceX's ability to rapidly iterate and address issues has set a new standard in the industry, making their rockets an attractive option for future Starliner launches. This shift could enhance Boeing's ability to meet its commercial objectives by 2025, provided they can resolve the technical issues with the Starliner itself. That's all for today's update. If you enjoyed watching and found this useful, please make sure to subscribe to our channel and hit the like button. Thanks for watching, and I'll see you in the next one.